What's going on, everyone? You're back with your boy Jono for another quick math lesson. Today we're going to look at how to rationalize the denominator when we're dealing with the topic of surds. Our goal for this is literally in the name. We do not want to have an irrational number or a square root on the bottom of a fraction. So they look something like this, 7 over root 5, and our end goal is to make sure that there's no root on that bottom of the fraction. So the trick here is to multiply something by 1, which I know sounds pretty dumb. So if I had 3 over 4 and I multiplied that by 1, that would be equal to 3 over 4. Wow, Jono, you're a genius, okay? This is an incredibly simple idea, but it's going to have really big ramifications down the line. The most important one here is that there's another way that we could write 1. We could write 1 as 2 over 2, or we could write it as 3 over 3. Both of these fractions, because the top and the bottom are both the same, are equal to 1. Even though this looks like a much harder equation now, this is just saying 3 over 4 times 1 is just equal to 3 over 4. So the first thing surds get introduced, we're going to see why this is really helpful to rationalize that denominator. So for this example, 7 over root 5, I can multiply the top and the bottom by a number that will get rid of the root 5. And that is by itself. So if I multiply this whole thing by root 5 on root 5, I'm still not changing my equation. It's still being multiplied by 1. But because a root of a number multiplied by itself just equals the integer underneath, this then becomes 7 root 5 over root 5 times root 5 is just 5. And that there has a rational denominator. The bottom is just an integer, so we know we got our answer correct. So even though all that explanation seems a little bit difficult, all you're doing is multiplying one thing by a surd, and then you're done. You do, though, have to look out for simplification at the end, because you will lose a mark if you don't fully finish it. So in this example here, I've got 6 over root 3. I don't even have to think. All I've got to do is multiply the top and the bottom by root 3. So the top there turns into 6 root 3, and the bottom turns into just 3. But here's where it gets a little bit annoying. This front number is still a whole integer, as well as the bottom, so I have to simplify these. So this becomes 3 goes into 6 2 times, so my final answer there is 2 root 3 over 1, but that's our final answer. For this one here, you can also do it when there's a surd on top and bottom. I still have to make sure I am only focusing on the denominator. Don't worry about that root 10 at all. So I'm just multiplying the top and the bottom by root 5, which ends up with root 50 over 5. You do have to be careful though, because if you can simplify that top surd, you must do so. So root 50 is equal to root 25 multiplied by root 2, all over 5. Root 25 is 5, so this is just equal to 5 root 2 over 5. The 5's cancel out, so my final answer there is root 2. So even though that looks crazy from what we started with, just by making sure we're using all our surd rules together, you're going to find these pretty cruisy. Finally here we've got 2 terms on top, and the only thing we have to do is make sure we multiply everything by the denominator we choose. So in this one I'm multiplying root 2 on the top and the bottom, so this becomes root 2 4 plus root 7, and I'm just going to expand that out, all over 2. This becomes 4 times root 2 is 4 root 2, and 2 multiplied by root 7 is plus root 14, and this is all over 2, and that's my final answer. I know that this doesn't look more simple than what we started with, but because there's no surd on the bottom, we're laughing. Thanks so much, guys, and I'll see you later.